I came to Kansas State University as the Agricultural Experiment Station Director back in 2001 and got very much involved with wheat as a research subject. I hadn't done much on wheat earlier. And I was surprised to realize that little or nothing had been done on sequencing for the wheat genome. I knew how powerful genome sequences were and how much more powerful they were becoming, and wheat was being left out. So talking with Dr. Bikram Gill at K-State and with people at the Kansas Wheat Commission, including David Fry and Dusty Gallagher, we developed a shared vision. It was really a shared vision from the start.
Rudy Appel and I organized international genome research on wheat consortium, and in 2002 we organized a workshop at ITMI meeting held in Winnipeg where we discussed this problem of the wheat genome sequencing.
It was at this time there was a lot of obvious excitement with the human genome coming out, and I think we just saw that if we're going to make any progress with molecular markers for wheat breeding, you needed the wheat genome sequence to really get the gene space, the bits in between, and to have really access to a much more detailed molecular markers than we had at the time.
I wrote a proposal to National Science Foundation and USDA on wheat genome sequencing, and this workshop was held in Washington, D.C. November 11, 12, 2003, and it was attended by 65 scientists, about 45 from the U.S. and about a dozen scientists from foreign countries. And also we had scientist Dolzer from Czech Republic made a presentation on the success of chromosome flow sorting.
We were there ready to promote our approach and our technology, so we were very much interested to be part of these efforts. So we were in the right time, in the right place, at the right moment.
Eversole Associates got pulled in very quickly. We had a past relationship with Kelly Eversole working on various projects, and it seemed like she was a good fit because of the role she had played with the corn growers.
I was asked to attend that workshop and then had discussions. This was in 2003, and then so I attended and had discussions with a number of the scientists there and trying to get a feel for what kind of project we might be able to do. So one of the things that was happening in the United States at that time, particularly and perhaps even in other countries, was the fact that the people were getting out of wheat because it was no longer productive.
Wheat growers, from the time I first began working with them, were clear in saying that they felt their crop was being left behind, that there wasn't enough research investment, and particularly the latest and greatest tools for plant molecular biology and genomics were not available for wheat. So they really thought for their industry to stay viable, they needed better access to the latest tools, which included sequencing the wheat genome.
In November of 2004, I was hired by Kansas State University and, more importantly, the Kansas wheat growers to actually come in and launch a consortium and to really move forward. We organized our first meeting in January of 2005 in San Diego. There was a lot of interest. One of the first things was, how do you actually go about it, who leads it, and things like that. So, we had laid out an organization with the idea of having co-chairs, and after the meeting in San Diego, there was a consensus that Catherine Fouillet joined as well.
The project that I was putting together was around doing a physical map of chromosome 3B. Then I came to the Plant and Animal Genome meeting in 2005, and there was this meeting organized by Bikram Gill and Rudy Appels, and they invited Kelly Eversole, and nobody really knew Kelly Eversole, and she made a presentation, and That was really a blast for everyone because she showed what she did before, working in the Senate, being able to put $30 million behind the project. So everybody was very impressed.
We rolled out circulated bylaws, established a temporary coordinating committee with a few people and that had an interest in trying to do something. One of my interests from the very beginning is to make sure we have application, that it's not just a fundamental science project. So we brought together these different stakeholders. We had, Bikram Gill, Forrest Chumley, who Rudy Appels, and Catherine Fouillet joined the fold. So, and then between those four individuals, working with me, we really reached out to a wide range of audiences and stakeholders, from growers to millers to the processing industry to academic scientists to funding agencies.
I think there was a lot of excitement. A lot of people bought in from an early stage, and were excited and convinced that we needed to work hard to make something happen.
Yeah, the wheat community was really positive. I mean, it was something that was much needed. The people wanted to get something happening, but each individual group was not really capable of raising the funds for it.
We got very good support from international organizations such as CIMAC, and there was also tremendous support from grower organizations as well as industry. Actually, in the US as well as internationally, there was a big question. Since wheat genome is very large, should we sequence the bred wheat genome because it's cost prohibitive, or and also very complex, or should we sequence one of the diploid progenitor species?
That's where the industry was very useful to tell us, well, actually we want you to sequence what is in the fields, and what is in the field is the hexaploid bred wheat and not the wild relatives.
We had a wide range of users, from the fundamental scientists to breeders to geneticists, to, that were ranging the entire scope of the spectrum. And so what we wanted to do was to have the best quality, not just having a genome sequence for the sake of ticking a box and saying there's going to be a genome sequence, but that we have something that would change the paradigm for wheat improvement so that productivity and agricultural production of wheat would continue.
I think what really changed, that was a real game changer, was when Jaroslav Dolizel in the Czech Republic was able to do the flow sorting of each of the chromosomes.
By dissecting the genome to single parts, to individual chromosomes, you can involve many laboratories around the world. So it becomes a real collaborative effort, which is really different from all other projects.
The very instrumental thing was the idea that Kelly had to put flags on the chromosomes. The day we put the French flag on the chromosome 3B and the US flag on the chromosome 3A, then suddenly the country said, oh, we cannot let this guy doing things, alone. And so it was really a brilliant idea to do that.
A lot of the wheat community didn't think it was still possible for us to do it. So we had a small community for quite a while, but slowly but surely there became more support as more resources became available.
And I think it was a snowball effect that starting the first project, showing that it works, then it triggered as well enthusiasm for other countries to join.
Challenging to work with such a large group and some people from so many different countries, different cultures, different funding schemes, but I think more than anything else, it was people who said we could not get it done. That was probably the biggest challenge, although it's one that I took on as okay, we'll pursue the objective, and we will convince you, and that's really what we did in a variety of ways.
Each of my colleagues had to sacrifice a bit of his career for the sake of the whole teamwork. I'm sure that it pays back, because now this laboratory in the middle of Czech Republic, in the middle of Moravia, it has links to all labs from Japan to USA.
It has been very hard work to develop this resource, but it's very rewarding when we see now this survey sequence of the wheat genome where each chromosome arm, all the gene space is available and all the breeders. This resource is widely used in gene discovery.
Perseverance, and maybe right behind that, innovation, because we were taking on such a huge challenge, and innovation needed to happen from one end to the other, but to get there we had to persevere. So that's 2 words.
I would say frustrating yet rewarding.
Satisfaction of achieving something people thought was impossible.
So a kind of a heaven's gift, to me and our laboratory. This is the feeling I have, and satisfaction, if you wish.
It's a great adventure. I mean, I think it has put as well a community together that really appreciate each other. From a human standpoint, it's a really great adventure. It's one of the few consortium that has survived the next generation sequencing era, because there were many consortia actually exploded when people could do things on their own. It stayed the same, people were still motivated to stay together and appreciate to do things together.
Cooperation is probably the best. People were so excited about actually seeing progress in a crop that had been neglected for so many years that, they really just jumped to try to cooperate. And that was the thing I feel the greatest about over the past 10 years, aside from the scientific progress. Yeah.